Let's say you want to find the antiderivative of this one. That's not so simple, because you can't just add 1 to the power and divide by 5. Because if you now take the derivative of this one, you will not get this one. Because the outer derivative, the 5 will drop down and cancel to that. So the outer derivative will give you this. But you also have an inner derivative. So if you take the derivative of what's inside the parentheses, and that's 2x, and there is no 2x here. So we can't write it like this. However, let's say that you have 2x in front here. Then you can do it like this, because if you take the derivative of this one, you will actually get this one. We can check that. Then we need to take the outer derivative. And that's just thinking of this as one big variable. And then you get this one, because the 5 drops down, and this will cancel now. And then we need to put back that here. So this is the outer derivative. For the inner derivative, we need to take the derivative of what's inside the parentheses. That's just 2x. And if you simplify this, we get this one. And this we see is just what we had here. So in this case we were lucky, because if you took the antiderivative of this one here, the inner derivative was standing in front of the expression. So we could just do it like this here. And then of course we should add a constant here also. So this is the antiderivative of that one. And the same thing works here. Although this one here is not exactly the inner derivative of this one. But if there would have been a 3 here, then it would have been that. But that's quite simple to compensate for. Because if you write a third here and a 3 here, those will cancel to 1. And now this is the inner derivative of this one. So now we can do just like here. So now we'll see that this one will work. Because we take the outer derivative, this will drop down, cancel to the 6. And we get 5 here. So then we get this one. But then we also get the inner derivative, and that's 3x squared. And that's standing here. But then we also had the third. To compensate for the fact that we didn't have a 3 here. And finally we just have to add a constant. So this simplifies to this. However, if one finds it difficult to spot these kinds of things, there is also a method called integration by substitution one can use. Let's do the first example again, using instead integration by substitution. Then we substitute or rename something. So let's call this here, inside the parentheses, y, for example. If we take the derivative of y, then we get 2x. And if you remember, this is an alternative way of writing a derivative. And if you for a moment think of this as numbers, then we can multiply up this here. So we get this one. Then we need to substitute this in here. Then we see that 2x times dx, that's what is standing here. That we can replace with dy. And here is standing y. And that was raised to the power of 4. So we see that by substituting a variable, we have made this an easier thing to find the antiderivative of. And taking the antiderivative of this one just becomes this. Now in the last step we just change back to the original one. And we see we end up with this one. And if you now compare this with what we had, which was this one, we see that it's the same as we got using the direct method. So this is the method of integration by substitution. And in the book you can find more examples of integration by substitution, but this is the method. So either you can do it directly like this, or you can use integration by substitution. If you can spot directly like this, then it's often the easiest thing to do. And this technique can just be an aid for doing that. And sometimes it's difficult to see directly what the antiderivative is, and then this is the way to go.